This is our project Task Force. Task Force is an innovative framework designed to streamline the process of creating and managing multi-agent systems capable of collaborating to solve complex tasks. This is a summary of our workflow, which we will get into more detail on through our software architecture, and the primary libraries and frameworks we're using are AutoGen, PyQt6, and LangChain. The user interacts with the system through the UI. In the UI, the user defines a set of agents and also a prompt that initiates the conversation. If the user doesn't want to define the agents manually, they can write a prompt to automatically generate the agents, which will happen through Agent Builder. If the user wants to include tools, they have to manually input the agents, and they can import tools through LangChain, or they can write Python tools themselves. So once the agents are sent to AutoGen, AutoGen facilitates communication to the TensorRT LLM server through the OpenAI chat completions API, and all of the inference and generation happens on the TensorRT LLM server, which runs on the user's local IP. And AutoGen and TensorRT LLM communicate back and forth. And once the conversation is finished, it is stored in the conversations and is displayed in the UI.
So talking about the UI, here's some of our Figma designs to reflect what we're actually going to do. So this is our dashboard tab. And on the left, we've got the chat area where the user can enter their prompt. On the top right, we've got our employees or agents. And then we've got our tasks underneath that. And this is pre-prompt. So this is what it looks like with a running process. Our employees get filled with these boxes of our agents, and they've got an image and a description to go along with it. And then the tasks are listed below with the status for each. Our agents tab is pretty similar to the part on the dashboard that shows the agents. It's got all of the saved agents already listed where the user can select and go through them to see their descriptions. And then they could also add a new agent, which Kelsey's going to get into.
Yes, so this is how we would add a new agent by defining their associated properties, such as their job role, description, their tools, and the type of LLM. This is the chat tab, which shows running projects that the agents are performing. And on the next slide, we can see how the chats can implement feedback by prompting user input throughout the process of agent communication.
Okay, so for our project progress, we'll start with some milestones. We've created the Figma designs as seen earlier, and we've also set up and began PyQt6 development. We've set up the TensorRT LLM server for inference, and we've also interfaced with the AutoGen library to mimic OpenAI chat completions API for agent creation. Some issues we run into and we know we'll face in the future is keeping the front and back end updates synchronous. Some of the designs from Figma are also incompatible with PyQt6, so those must be changed. We're also working on getting access to Hypergator to efficiently run the desktop app. And we've also run into issues with different operating systems because TensorRT, for example, can only work with Windows and NVIDIA GPUs. So we need to set up Ollama for Mac and Linux computers. And then for our implementation plan, we need Python code to implement components for the AutoGen library. We also must direct chat and completions API to a local server endpoint for the inference. And then we have to hook up a PyQt6 user interface to AutoGen components for the agent creation. So some strategies we have to implement this are building the front ends from small components to larger groupings. We also want to create the user interface with seamless and intuitive purpose. And then we also want to focus on functionality first and then improvements and scalability later.
As for individual responsibilities, my plan for the rest of the project is to consult with the backend and update any necessary front-end design changes. Then I'll translate the designs from Figma into PyQt6 code. And then finally, I'll ensure that the code organization is optimized for code reusability and readability through refactoring.
My plan for the rest of the project is revolving around the use of multiple models and the efficient use of the GPU resources. So if we are using multiple models, or if the user decides to use multiple models, you have to make sure that each model's inference server runs on a different port since they're all running on the same local IP. And my plan to check for that is writing Python scripts to programmatically check which ports are in use. We also need to prevent model use requiring more than the user's available VRAM. There's a limited amount of video memory on each GPU card, and each model has a different requirement depending on the number of parameters. So we can also write a script to check the user's GPU requirements and resources. Also, I need to write scripts to create the TensorRT LLM engines optimized for the user-specific GPU and model that they have chosen. We need a different inference engine for each model, and the optimization is dependent on the GPU. And then if using multiple models, we need to choose from the most optimal assortment of models for each agent. Each agent can optionally use a different model, and the generation of all of their chats can come from a different endpoint.
I'm going to be responsible for adding interactivity between components and pages, as well as connecting the front end with the back end. And I'm going to be using threading to allow for synchronous processes in the front end and the back end.
For my responsibilities, I'm going to start by setting up the new version of Ollama to interface AutoGen, so you can run large language models locally for Macs and Linux. And then I'm also going to ensure that any changes in the front end are properly represented in the back end. Thank you.